Test, test, test. 1, 2, 3. Hello, everyone. We are live again. Well, I mean, it's a bit early, but I've got everything set up now, so I might as well start. Greetings. I hope you're doing well. I'm doing very good. Also, I really don't like this camera angle, though. Yeah, I know. I'm a bit early. So let's see. Maybe a bit further back. Not so sure about that. I think it's okay. Let's see. But yeah, I'm doing well. Thanks for asking. I hope you're doing well as well. Getting more professional every week. Soon I'm gonna be a streaming expert. Let's see about that. So let's see. That looks like a more interesting angle, doesn't it? Whoop. Okay. That's very good. That's very good. I hope you will get a new computer soon. Maybe you can join in-game sometime. Yeah, so I guess I should probably take the starting soon thing away. And I should probably also... that's fine, don't worry. Neos is very playable in desktop mode as well. There's plenty of like free models that you can just choose from the like the default folder you will have when you create an account. So that's not going to be an issue. Let's see. Okay, the text is completely wrong. I might as well completely leave that out, I guess. Unless I can find my notepad. Maybe I can quickly... I'm also going to open this the server up. So let's see. It is anyone can join now. It's not hidden. Perfect. There, on-screen text. Do. Oh, I think I actually had... something like that. Almost. And I can copy that. OBS, yes. Editing stuff in VR is always fun. Let's see. Where's my keyboard? Boop. I said boop. Yeah, that looks good. No, wait, I don't need 2 lines. 1 line is good enough. There, perfect. Cool. The element is partially not on screen, but no one is going to notice, so I'm just gonna ignore it. Yes. Okay, so officially maybe a couple minutes early, but I mean, why not? Welcome to the weekly creator workshop. Yay! I'm Jack, I'm gonna be hosting it. And I hope you're all having a beautiful day. So just to recap what this is all about. Basically I'm gonna try to do this kind of as a weekly thing where I do this workshop, everyone can come in, it's like a public world. And I'm also streaming to Twitch and to YouTube, if nothing died. So far looks good. Well, YouTube is still throwing arrows at my face, but I have no idea why. No, I don't think so. Yeah, I think this is gonna be pretty fun. The idea is, this is a public world, everyone can join. I'm gonna help you with your projects if you have projects that you're stuck with, or I'm gonna try to explain some things, or if you're completely new, I'm gonna try to walk you through the basics. And everyone in chat and in the world is encouraged to just ask questions, and I'm gonna try my best to answer them. It's probably going to be a couple of hours again. Not quite sure how long exactly. Also, I think again, I don't like the static camera angle. Still tuning this in. Also, I didn't save the world, right? I think I already did this last time because this light is really bright. So let's change that to something. What did I use? 75 maybe. Do the same for the other light. Need to tune this in at some point. I could do it now, but I can't really save the world because it's now hosted on a headless and the headless isn't the owner of it. But it should, like, hosting it on headless should make my computer not die so much. So I think that's a very good idea. Yeah, so I'm not quite sure where I'm gonna start. It's kind of gonna be a slow start unless there are questions. I think that's just gonna be something that everyone will get used to when they start streaming, that you kind of have to talk to yourself for a while until people actually show up. Which isn't the worst thing. I mean, I'd actually talk to myself probably more than I'd like to admit. So this should work, although I should make sure that I'm not actually running into any walls here. Let's center myself in the play space. Okay, so I hope... Oh yeah, I already said I hope you're doing well. Well, this is Neos. I mean, you've probably already seen it, maybe not. It's a nice real-time environment. Yeah, you can join in VR or in desktop mode, you can build worlds with your friends, you can hang out, you can socialize, and you can also create content. You can edit anything you see in the game. I could, for example, edit my hand in real time. I can also program in the game, because Neos has a pretty nice visual scripting language, which is called LogiX. Well, I mean, it's a bit hard to compare Neos with VR chat because the two have completely different focuses. I mean, VR chat is basically like, as it said, like a chatting application in virtual reality. So you can like hang out with your friends and chat. It's not really a real-time environment. It's a pretty good walking simulator though. And I mean, they do have some pretty impressive games over there as well. But it's not something like with Neos. It's basically more akin to the likes of Garry's Mod, where the entire game is basically both the game and kind of also the editing environment at the same time, where you can really, really get far and have fun, create stuff. For example, well, we can do the same thing that I did last time as a little demonstration. So let me switch to POV here. So you can see I am currently holding a nice tooltip, which is the LogiX tooltip. And that allows me to program things. I can spawn this little node browser here. And I can spawn nodes into the world. Also, maybe I'm gonna quickly turn around, take the chat with me. There we go. There. So let's start with something simple. Let's start with a node, t divided by 10. T is the time in seconds that the session has been up for, and oh, I actually restarted the headless this time. Wow, I must have been very smart. So yeah, as you can see, you can just spawn nodes into the world. They are connected by wires, and they are real-time, as you can see by the number changing. So what can I do with it? I can build logic. For example, there is a node hue, which basically gives you the color for a given hue on a 0 to 1 scale. So if I hook a changing number into this, you can see I actually get a changing value out of it, right? So I have a number and I turn it into a color. It's all real time. And what I can then do is, it's nice that I can make programs and stuff, but the really powerful thing is that I can just take this program and connect it to the wall. So I could, for example, grab the model over there. Or let's probably take this one because I know this only has one material. If it wouldn't steal my inspector from me. So you can see we have a table here which has a mesh renderer. So this is just the 3-dimensional mesh that's being rendered here, and it's using a material to display it. And what I can do with the LogiX tool is I can grab that material, I can pull out an interface card, and I can also actually get it out in the worker inspector here to show it off. So basically, material, it has a bunch of settings, like it has it in texture, colors, it has some scaling, tiling options, and you can, like, these squares here are basically texture inputs. So for example, here's the nice marble texture that's being used for the surface of the thing. But using the LogiX tooltip and pulling out an interface card means I can take all of the things that I could configure here manually and configure them by code. So for example, here we have the albedo color, which is the same as this one. So if I change this, you will notice that actually everything here changes color. But what I can do is I can grab the little program here that we wrote, I can connect it to the albedo color, and now you can see the color wheel is turning because we are cycling through the hue. Right, it's going through all the different channels here, and you can see everything is now very RGB. Yes, not just the floor. This material is actually used everywhere, so the entire building is now a kind of disco accent. Yeah, why not? I like it. I'm just gonna show this off every time because it's my favorite thing to show people. How you can just program stuff together. And also I think I'm gonna quickly do that. And now I'm gonna do the real fun thing, and I'm just gonna take my code and put it on the table. There, why not? Show off the code. Nah, it's not. It doesn't cost $9,000. It's free. Neos is free for everyone. You can just grab it on Steam, you can install it, and then you can hang out here. No charges or anything. Okay, it's a bit weird to try and stack code like this. It's not really intended for that. Oh, I wonder. Oh, I think I can probably only stack it on the wire. Okay, wait, then let's do it this way around. So I'm gonna do that hue there into the PBS metallic. And then I can probably stack this on top of it. Yay! Kind of. Let's not make it that big. Whatever, perfect. It's beautiful. We have code on the floor. That's the best place for code. So, whoop. Back to my funny camera anchor. And now you can see the code in front of me. Yeah, so, once again, I am not very prepared. I'm not quite sure what I'm going to be working on while I'm waiting for people to show up. So, let's think about it. I have a couple of projects going on right now. Most of those are a bit too big to be working on stream because I will actually need to like really focus on it. Last time we did this little thing here, which is a little box we built in the last workshop. And I can move it around. Okay, let me actually go to smooth POV again. I can move it around and you can see that it always points in the direction it's moving. Which was a pretty fun little project. I also noticed this is really bad for everyone that's not currently holding it, because I'm doing a lot of like interframe estimation there. But I don't care because it looks good if I'm doing it. Okay, so I have a bunch of different projects. Ooh, and I have people joining. It's Shadow. Nice. What code are we working on? Couple of things. I have this fun world map that I could maybe work on some more. I know I finished that project. I could also try and do the... Okay, so one idea that I've been having for a while is basically I wanna... well, I do want to create more educative content in general. And one way of doing it, I guess, would be to do like proper little tutorial snippets for LogiX. I already have a bunch of scripts that we created for the presentation we held about the calendar, which I don't actually have here though, so I can't really work on those. But that would also be something that I could be working on during the streams. Hello, Shadow. Greetings, welcome to the workshop. I hope you're having a good time. Wait, let me group mode. Which was the group settings? Why do I always forget this? Oh, users, right. No, that's focus. There, now it should include you. No, it doesn't. Neos, why? Oh, wait. No, I think I want... Yeah, that one. Yay! I can totally use the camera tools in here. Also... Nah, very good. Also just noticed, as much as I like Basement's video, it's kind of a bit in the way of the camera. Oh, I think I already removed it. It was just the leftover, like, culling visual. Perfect. Yeah, so we were just trying to figure out what we actually want to do during today's stream. Couple of ideas. We did the little Bezier curve presentation last time. I might start this again because I had a pretty fun idea of turning that into like a proper visualization of the math. Which definitely will require a little bit of figuring out how to do, so that might be fun. Just not 100% sure how I want to make it, so that could also get pretty boring to watch if I don't even know what I'm doing myself. I have the live chat here, which still needs some features, but those are on the backend side, so I can't really work on that right now either. And I have the world map, so world map or Bezier curves. I think I want to try Bezier curves. So let's spawn this thing, which I already made at some point in the past. Oop, and it's falling on the ground. Perfect. Yeah, okay, so I think the idea here was this isn't actually doing anything. Okay, so let's see how far were we with this. Not very. Also, why did I not pack this with red print? Ah, Yuki's gonna hate me. Let's unpack those. Well, they do look semi-aligned at least. Too many interface cards. Okay, let's try to fix that quickly. That is definitely something we can do. So let me grab my handy little red print tool and let's see if we can quickly grab those nodes. I don't think I actually aligned those properly last time, so I might have to do this manually. Why is this napper so far? Ah! Okay, can I actually change this because this is getting really annoying. Tween time, no wait, can I not change how far away that thing grabs? Is it based on scale? Oh, that's annoying. Oh, I can do a check offset. So if I do this a lot smaller, no, not small enough. Does it even work? Nope, I don't think it works. Okay, you know what? Grab will receiver surface. Enough grabbing for today. Because I need some of this to look nice. Okay, so let's see. Let's destroy the broken interface cards. I'm still looking forward to the day that bug is gonna get fixed. Right, so that was basically just, a lot of this was still me trying to figure out how to do the, how to align the, well, the line in between those. There is a slider input, okay. So we had the lerp here, which we can use for a point that's moving along the thing. And let's see, so the idea here was, I think I was just using look rotation, that's a tube wire mesh, okay. So I have 0.0, 0.1, that seems to be working relatively well. Right, so we can have a wire in between those points. Oh, although I can't, okay, none of these have colliders. So this should already basically be stuck to it. Come on. Yep, that looks like it's pretty stuck. Very good. Now let's see about what's up with that music. Let's try something that's a bit more backgroundy. Yeah, so the idea basically here, this is the same thing that I showed off in the last stream, using a very fun mathematical construct here of just basically linearly interpolating between multiple values, or in this case multiple points in space. You can create curves, Bezier curves to be precise, and shadow left. I don't know why this world is such a massively overly loud joint sound. And I have no idea how I can turn it off, because I jump every time someone joins or leaves. Map assets? No. Info, simple math nodes, no. That seems to actually be all the examples. AFS? Oh, that's the culling system, I think. Yeah, I do still have no idea. That's the mantra signal. Where that audio is coming from. It's coming from somewhere, I just don't know where it is. Might actually be one of these examples, thinking about it. Maybe not. Cube touch. User scale. Maybe not. Well, I'm gonna maybe figure it out at some point, or not. Maybe never. Who knows? Yeah, I don't think these are where the systems are. This really does only seem to be the actual building. Well, whatever. Gonna have to live with the sound then. Just wish it wouldn't be so loud. So right, we have basically multiple points in space. We can plot a curve with it, but what I'm most interested in right now is these lines, because I think my idea was I wanted to have multiple lines in between there. We have 0.0, 0.1. These seem to basically be the rotation of the thing. So if I select P1 again and I move it up and down. Oh, nope, not what I wanted. Yeah, so basically it's always rotating the cylinder that it's using to display the wire to be facing the ball. So what I guess I only really need to do now is, instead of going directly to P1, because I probably want to animate this, right? That's the idea. I would likely want it to go from left to right. So I would have to give it a basically move P1 to be a linear interpolation. I want to say we need more lerps. Because we can never have enough of those. So let's see, we have... Okay, that's actually, because this is getting a little bit annoying to work with. Let's actually put those into relays, just so I can collapse these cards and they aren't in the way, and can still draw new wires. Okay, so we have one more lerp. I guess it kind of depends on how I want to animate this. I think my idea here, I'm trying to remember because it's been a while. I think the idea was I would have an animation that starts at P0 and then it goes to doot 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 to connect them up. Oh, it could actually do like a little particle effect or something there, like of an expanding sphere. I think you can do that with particles, or I can literally just spawn a sphere. So let's see, for that, so start point is going to be P0, and then it's going to be P0 to P1 based on a factor. So right now that factor is 0, so if I do that 1, it's the entire thing, and 0.5, it's half of the thing. Which means I can now animate this. I'm probably gonna have like one LogiX that's actually controlling the visual, and then one that I'm gonna display, because I think all of the masks for the lines I kind of want to hide away, because it's probably gonna be distracting a little. And it's also not gonna be very nice to look at. Yeah, that's basically the idea. So that's our first, and then we have a lerp to control that, and we basically want to have that for all of the lines. Yeah, let's see. Can I make this less ugly? Probably. Question is how. No, I think this is probably fine. It's a bit hard to see what's going on there, but it doesn't have to be beautiful. This is just for the wires themselves. So let's basically create one of these for every line. So what do we have here? We have P0, 1, 2, 3 graph visual lines. Yep, and then we have L0, which has its own material. I'm gonna try to think about how to make it nicer in a bit. Let's start by just creating all the lines we need. So we have L0, then L1, then L2, and then L3. So we need actually 3 more lines, but let's start with these. So let's see, L1 we will need the tube wire mesh, and then L2 we will need the tube wire mesh, L3 we will need the tube wire mesh, and now we have all the meshes, and we basically just do this a couple of times. So let's see. Now for this one we will start there, let's put it in the middle there. For that one we will start at P1 and go to P2 based on the lerp. So start at P1, just gonna be that one. And then go to P1 there based on the lerp. And then we do the... So what did I do there? Just P1 minus P0. So now this is gonna be P 2 minus P1. Look rotation, right? Those should be the same, yeah. And then we just go orientation for both of these. Also, let's, for now, just so we see it's actually correct, set this to, I don't know, 0.75. Right now we have 2 almost finished lines there. Oh wait, actually I just realized I already created one too many. Well, it's fine, we will need them anyway. So this is gonna be the entire first line and second line. Let's see. Now let's just do that one more time then. So now we lerp from there to there, 0.75, and we subtract that from that. P0, P1, that's the tangent. I fucked up the tangent. That's not a very straight line anymore, no! There, you should be 0, please. Thank you very much. Appreciate it. Alright, and the orientation is still missing, so... oh wait, actually no, this is wrong. What am I doing here? So I want that lerp for P1, and then we just have this one straight into P0. There. Look rotation again. And those... What? No, look rotation. There. And orientation 0, as well as orientation 1. Nice. So now we have our 3 lines. Now they actually look properly. I'm very happy. So we could probably now already animate those. But it's not gonna stay at these. We will need more. So we have the point visuals here. We are gonna have 2 more points. No, 3 more points. And 2 more lines. I think maybe I'm gonna do the lines first, all of them. So this is the first layer line. The second layer is going to be, we will have a point based on these lerps here. So we're gonna have 2 more lines. Not anymore based on the origin points, but now already of the intermediate results. So let's just move all of this over a bit. We have RT down at the bottom. It's about 0.5 right now. Right, now we want to basically do the same here. We have, for that line, we start at the intermediate result 1, and then we lerp from that based on some new progress for the lines. And we're gonna do our little look rotation thing again. 2, 3, 4, 5, 6. Just realized I should probably align these, because otherwise my OCD is gonna kick in again. And then I can do there, there, and there. Perfect. So let's see, we go from there to there. We will do the look rotation from that minus that. And that's just gonna be both orientations. Oh wait, no, that's wrong. Can't even copy my own code. Why? Okay, so now that negative minus, not the other way around, that minus, wait, what? That's wrong. There we lerp to there. That is literally the same as that one. There we go. That looks better. And then we do for orientation 0 and orientation 1. So I can once again just align them. Beautiful. Now can I make that any nicer by any chance? Yeah, I can do that. And now I might just connect them directly. Yeah, it's already still connected. So that is the first line there. Yeah, this does get pretty messy. Well, that's fine though. So, and then we want to do that entire thing one more time, but we need another line. Why do I not see line 3 right now? Oh, because it has no progress. Right, so if I actually set the progress to 1 here, I think you can see where I'm going with this. So you see now that we get to go from the center point on there, or not the center point, but the point that's defined by the t value. And we move from there we draw basically an intermediate line, and we want to do the entire thing once again, so let's do L4. This is just gonna be a little demonstration that I wanted to do for a while. And I guess I do have time for it now, so why not do it? Yeah, the inspiration for that actually came from the Freya Holmer video that she did. An amazing YouTuber that's like very knowledgeable in math and like shader programming and stuff. And she did a video on Bezier curves. I actually did multiple videos on it, but she did like a new one. And I really enjoyed that, and I think that actually inspired a bunch of people in Neos to like look into more Bezier stuff again. I mean, I am still planning to make something that's not just a little display unit. It's wrong. All of this is wrong. 0.1 and 0.0. There we go. I already started working on like an entire tool for creating paths, and this might actually get pretty relevant for the entire streaming thing that I'm doing here, because I want to now, also inspired by the multi-camera switcher that Zeisel made, I definitely want to see and get into creating my own custom camera system to move everything around and stuff. And I want to make smart camera anchors in a way, and then actually build a proper streaming studio. This one is just borrowed. That's just the Mentor Team Workshop world. So this thing is gonna have a bunch of drives, but that should be fine. I mean, it's a demo unit, and none of this is very complex. So yeah, I will probably look into that as well at some point soonish. I mean, we could probably play around with that as well, and on stream if no more people show up. Otherwise, it's probably gonna get a little distracting if I build like camera tools while I'm having the workshop stream. That could confuse viewers a little, I guess. So L4, and now we just have one last line. L5. That thing to wire mesh, and let's build the entire thing one more time. Once more. And let's put my input up there. Okay, I swear we're almost done with this. This is extremely repetitive. Okay, so we want to lerp from there to there based on that. Can never have enough lerps. And we want to subtract that from that. Get the look rotation. Can't really spawn driver nodes like that. Oh, I think I'm standing. Yes. Try not to face away from the base stations. That's just gonna mess up tracking. Okay, we will take the position 1 for P0, and then we will take the position 2 for P1 and collapse that so it's not so it's out of the way. Right. That is already basically it. So we have all of our lines here. I should probably explain this a bit more, right? I mean, the general idea is if you like linearly interpolate a couple of times, then you get this very nice shape out of it. And if you track a point at the t value there, and you like draw it as you go from 0 to 1, then you draw a nice little shape. And that is a curve, a Bezier curve. Which I mean, this would basically be like on if we'd like put a point on each of these intermediate steps here, which I mean I probably want to do. And now though, let's create a nice little second slider. Just for visualization, I'm playing around with everything. And instead of having my static value input up here, I want to up to the relay. There we go. And now replace this with the value on the slider. And I can collapse the entire thing again. Perfect. That looks very funny right now. Yeah, I probably don't want to lerp them at the same time. Okay, so I can draw the lines. Okay, let's actually take a look at this a bit more, make this a bit more pretty. I mean, we probably will want to use unlit materials for those as well. I think the point here is was just a pretty... Oh, really? I used the 2 material for those? I probably shouldn't. I should use unlit. I think that's what I'm gonna do. But I think I want these to be a little thinner. I mean, I could also do it a very, very funny where I leave the outer ones thick and then the inner ones I do make a little bit thinner. Where do I choose your radius? So instead this is 0.5, so I could do this maybe 0.35. And then here as well 0.35, and then on the last one 0.2. Right, so now we have lines that get continuously thinner for the 3 layers that we have. I probably also want to map that differently. Yeah, I likely just want it start as P0, then go to P1, then P2, then P3. And then I want to make like the intermediate points appear. I think that's gonna be pretty fun. Oh, I actually didn't want to pack that. Or maybe I did, I'm not sure how much more I'm gonna do with this. I mean, would that be even a good demonstration? I guess so. I mean, if I do make this like an interactive thing with like chapters where you can click through everything. Yeah, I could make this kind of nice. Though I really can't use the 2 material for that. Might just fake the outline with an unlit. Because that's gonna be pretty expensive to render for such a simple preview. So we would have a little bit of math. Yeah, I'm trying to think what would be good kind of tutorials that you could build. I mean, we could build that further. Let me actually grab my chat and let me also, where's my camera panel? Oh wait, the camera is already following me. Let's do third person again. So what else could we build here? I mean, what Autopilot and me came up with. Question is, where did I save it? Did I even save it? LogiX examples. Oh wait, is that all of them? Oh no, that is a couple of them. That's the ones that I used. These are the examples that I used in the presentation that we did, where we start with like data and control flow. So we show the difference between the two in LogiX. We do a very very simple example before between Python, like a simple Python program, and LogiX. Same thing would look in LogiX, and then we do a little. We get a bit more advanced. We say, okay, let's calculate the triangle number, which. Which takes a loop and then calculates for any given number basically 1 plus 2 plus 3 plus 4, and you do the n steps. So in this case 5 steps and you get 55. Or you do it 5 steps, or you do it... Oh, 5 should be 15, I didn't click the button. Yeah, 10 was 55, okay. And then we calculate a little Fibonacci sequence. And I am still pretty happy about this. And something like this you could probably turn into some examples as well. First of all, I'm gonna have to make them bigger though, because they're tiny. No, I just went close. Why use so small? I think they're still small because LogiX examples. that small. There we go. Hello there, Kelmore. Welcome to the workshop. It's pretty quiet so far, but if you have any questions, feel free to just drop them in the chat. And I'm gonna do my best to answer them. Right now we're just going through some examples that I wrote for the presentation that we did for the Neos Educators group. And I'm trying to think about how you could take these and turn them into a proper, into proper educative materials. I kind of want to make like interactive experience. Yeah, interactive examples, I suppose. I think I changed those around. Oh, this is fun. No material. And then I... control and data flow, but without me standing there explaining everything, it might need some more annotations. Although annotations are kind of always a little messy. I wonder, like, if we actually do this like a little in like an interactive presentation style. Oh wait, actually that belongs there. If you do this in an interactive presentation style, then I would probably want to have hints appear that are like, hey, you know, click this button, try it out, and then you can see, oh, it actually works. And if you change it, then it changes, it pulls the different wire. And down here we have the data flow. And you can change this in real time, and you can see how in real time the numbers change. So we have the more declarative style of programming and the more well, functional kind of programming where you... No, wait, no, this is the declarative, imperative and declarative. I'm bringing my terms together again. Right, so imperative where you tell it, hey, you know, I click this, like, first do that. If that's true, then do that. Otherwise, do that. And then that's the, like, imperative style. And then we have the more declarative kind of style where we say, hey, you know, we want the result of 5 times 12. But we're not telling it, like, how to evaluate it. We're just telling it what to do. Basically only the pure logic, and it's always like, and Neos takes care of everything to make sure that this value here on the right is always up to date with the correct result. Then a little example here to check if a number is even. Once again, kind of more imperative, because we say, okay, I mean, okay, it's kind of a mix already of the two, because we have the checking here of if that number is even or not. For example, we have a 12 here, we pulls it and says, hey, this is even. And we change this to 13. And we pulls it again and says, hey, this isn't even. Then this is very imperative of literally just looping and iterating and incrementing numbers and adding them together and stuff. And then, of course, Fibonacci sequence, again, very imperative style of generating it. Although this is something that would be kind of hard to do declaratively, at least if the end result is supposed to be a string. But yeah, the cool thing about LogiX is that it kind of, like, you can use both, like, paradigms kind of interchangeably, more or less. And you just stop thinking about it, you just write down the logic of how to evaluate it, and you don't care about how the computer actually does everything internally. And then for your control flow, you still want to make sure, okay, but first you do that, then you do this, and then you write the result into the register there. Right, so I can say, hey, I actually want a shorter one, give me only 8. And it's giving me a shorter sequence. Or I can say, hey, you know, I want a lot more. And it's giving me a lot more. Oh no, wait, that's overflowing. Ah! Okay, how much can I do before it overflows? That looks fine. Yes. Basically, that's just... Oops. Don't steal my chat, red print. That's just a little... I mean, we do need to store basically 2 integer values here. And... I mean, this was easier than having 2 registers here because that makes the code a bit cleaner. I also do definitely like this pattern of using write ledges. I actually do need to use these a lot more often, where it's like we use it first on the first impulse before the loop starts to reset our value to the initial value, and then on the iteration, then we actually increment it. I mean, these like they have the same size, the 2 nodes and the inputs line up, like they're very, very nice to use together. And then the same thing back here, basically, just because when you write traditional programs, you have the state of the program hasn't run yet, right? And so you can, I mean, in this case, it's also like explicit, where I say, hey, A starts at 0, B starts at 1. But in many programming languages, you can just say, hey, you know, I need an integer, and it just defaults to 1 with defaults to 0 without you explicitly giving it a value. And then if you run the program again, it will once again start with 0. But if you do the same in Neos, because everything is persistent, if you run it once and then you run it again, then unless you actually do explicitly reset the value of that variable, well, I mean, I'm pretty sure you can do that in C. Like you don't, like if you just, if you don't assign a value to an integer, it will just start at 0. I haven't done C in a long time though. Also, that thing up there has a very interesting drop priority. Maybe. I mean, as you may be able to see, I'm mainly a Python programmer. Well, I mean Python and LogiX at this point, because I'm doing quite a lot in Neos. I did learn some assembler, and like in technical college we started with... Okay, no, actually we did start with just hardware, like building our own little dev board based on an old... I forgot which processor family it was. 8051 something. I think Atmel. Yeah, I mean, I have done some stuff in C# as well. I mean, some stuff. I basically work like professionally with a C#-like language, and I say C#-like because it's technically a custom language, but it really just like compiles to C# bytecode. So, I mean, I have the entire like C# function library at my hands. No, not quite. It's not Java. I wish it was. And that says a lot. But so, I mean, I can do some like C# as well. I do want to get more into writing mods for Neos as well. So that's definitely going to be a very good excuse to learn more C#, like native C#. But my go-to language is, at this point, Python. Because I don't know, I just like the syntax, it's very clean. It's very easy to understand. It's not strictly type, which most people see as a disadvantage, but I'm like, no, I want my dynamically typed language, please. No, that's like a very controversial opinion there. Yeah, I mean, it's understandable. I mean, I do use type hints usually whenever I write like an actual library that I want to reuse. But I mean, in many cases, I just don't bother because it's, I don't know. I mean, it can cause a lot of weird bugs if you mix types together. But it's also just, it's just comfortable sometimes. But yeah, I mean, I have the entire backend of this chat running in Python, and I mean, so far it didn't crash, unless people have been chatting in YouTube for a while and they haven't got a single message. Nope, they have not. Figuring out types for you is nice, ones where you only need to specify the types of the parameters and it guesses the rest. I mean, I don't know about that one. I think you either have like dynamically typed languages or you have like statically typed languages. I haven't really heard of a language that just guesses types. That kind of sounds concerning, honestly, because usually you don't want too much guessing in programming. Really? That Rust does that? I thought Rust is extremely statically typed. Like, wasn't that the entire deal of the language, that you basically, like the compiler is so strict that you can't make any errors? Or like that a lot of errors are basically just impossible to write because the compiler wouldn't let you? Ah, okay. So, yeah. Fair, I guess that works. So it's not really guessing, it's legit just knowing, just like while the compiler's going through and figuring out, okay, which is actually what, based on what the functions return. I guess that could work. Although I can... Yeah, I guess that could work. I haven't really done any Rust yet. I kind of want to get into it at some point, but my time is somewhat limited. I'm gonna focus on the things that that do the most for me, or like that I can use the most right now. I basically just use, yeah, I mean just use Python, LogiX, the custom C# thing at work. And I think that's kind of it. I've kind of gotten pretty lazy, so I definitely will need to get into C# as well to make more or like just in general start making mods for Neos, because I have a few pretty cool ideas for mods. But the issue here is that I probably don't actually need, like, the thing with Neos is it's amazing that you can just program in-game, like you have the in-game language. Okay, you have a good time then, bye. But yeah, what I like about Neos is that you can just like do everything in-game. A lot of reasons, or like most things where I was like, hey, yeah, you know, I should probably, like, I want this feature and I don't think you can do it in LogiX, so I'm just gonna like write a mod for it eventually, and then I realized sometime later, oh, actually you can do it in LogiX and I have no need to write a mod for that. Good example of that was the camera system, actually. Which I was like, oh yeah, camera anchors, they are pretty like close, like, because they are kind of communicating with slow user space components automatically, and you can't really hook into that. So I was like, yeah, I can't really like make any custom logic on top of those. But then I saw how Zeisel did it, and he just made his own anchors for cameras that the default camera just parents to, or the default anchor just parents to. And that's like so ingenious and also pretty simple. No idea why I didn't come up with that, honestly, when I was trying to find solutions of doing it. It's definitely something I want to look at more. Let's see. I don't think I actually saved anything. So far I was just experimenting with different things, like the camera exclude tip, which I now actually have as part of my multi-tool. Exclude. Where did he go? No one knows. There he is. I do like this thing. Okay, so I think though this would be a pretty nice tutorial. I'm just like, I mean, just making a world where all of these are, and you walk through the world and then you like read the things. It would work. But I feel like it's not really interactive. Like, I mean, or it's not like a guided experience. I would kind of want it to be like, maybe similar to the slideshow system we actually built. Oh, that would actually be a really good way to just make that with the slideshow system. Interactive experience, and the user themselves just toggle through the slides. Ah, yeah, that's actually a really good idea. I really won't get around building that tool, right? So we can have proper slideshows. I have also my... Maybe I shouldn't start 20 things at once. Maybe I should... Yeah, these are good ideas, but I think for now I am going to go back to the Bezier curve example here and try to continue working on that for a bit, because why not? So let's go to smooth POV. Well, actually, I will go to smooth POV in a moment. I will quickly have to drink something, and I just realized I am once again not centered in my play space. There we go. Sorry about that. Okay, so where was I? Right, I wanted to... Yeah, so let's take a look at that. So let's see about animating that a bit. Oh, that's gonna... I wish these would sometimes just spawn already collapsed. Just quickly collapsing them together, deleting the broken ones. Oh yeah. This really is a bunch of interface cards, huh? Maybe I should refrain from packing this more. Oh, not what I wanted. I wanted to actually go to fly. Okay, let's see. So that, you be gone, that, boop, boop, and boop, and you are broken, you are not broken, there, and there, and there, and there. Okay, so back to the drawing board. We have our simple code here so far. And right now we are basically having one slider value which going from 0 to 1. I don't think I want this. I think what I want instead is... what I want to have instead is one T range for all three on the first thing. So what we would probably want to do is we just have a 0 to 1 range from the slider. Okay, let's actually cap all of these to 0 for now, so we only care about the first three, right? The others are just small. And let's see, we want we take our input here from the slider. We multiply it by 3. Let's actually do this down here. We multiply it by 3. And then we do multiply by 3 and we do -3, right? No, not what I want actually. Wait, so let's see, this is 3 now. And I want it to, from 0 to 1, I want it to control the first thing. So what I can do is I can just leave it like this and just cap it at 1. So, because right now if I were to just connect that to the lerp, you can see that now the slider is only, when it's 1, it's, oh no, actually that does work. Oh yeah, of course, because lerps are already clamping. Nice. Then we can do it like this. So we multiply by 3. And then we subtract, because if they are already clamping, then I should be able to just subtract 1 here. Does this work the way I think? Yes. And then for the last one we just subtract 2. That's nice and simple, and now we have all of these. So this only really, oops, -2. This only really works because lerps internally are just always clamped, apparently, which I didn't know, but that's very good to know. So these don't actually extrapolate. Which is, I want to say probably fine in most cases. So now we have the slider here, and it makes the line go from there to there to there. And I guess I could make some, I could just spawn some impulse visual at those points then. Yeah, just let's see, we just take that one, we do larger than 0, then larger than 1, and larger than 1 and 2, right? So right now if we are at 0, these are all false. And then if I, let's hope the reprint doesn't steal it. Oh, also I should probably go to smooth PV again. There, now that one is true, now that one is true, and then once we're there, now that one is true. And if I just get an impulse on all of these, local fire on true. If it's localized value for the visual, local fire on true. Okay, let's set that to 0. Right, so I basically just replaced these with impulses, or rather I derive impulses from those. And now 1, 2, Why does it pulse multiple times? Oh, because that thing jitters, I guess. So we probably want a local impulse timeout for all of these then as well. So it just, so what this does is, because the slider kind of bounces a bit sometimes because your hand movement is a bit jittery. What this does is it basically just puts all of these impulses on a little timeout. Let's say a second. So after they pulse, they can't be pulsed for another again for a second. And that should already clean that issue off. So now if I go to 0, nothing pulls, and if I start here, why does that not work? It should have what? Why did that not time out? That's seconds. Why did it pulse multiple times? Oh no, because there's 2 users in the world. Because this value is synchronized. Okay, that actually makes a lot of sense. That... Okay, so... Was it only an issue there then? Yeah, I think this is only an issue if what we do is, like the end result here is something that gets synchronized to the data model. But I think what I want to do, so this is fine if this pulses for everyone, because I want to make that this visual here basically completely local. So what do I mean with visual? I want to see about P0 here. Want to add another thing here, and I'm going to call it highlight. And that's basically just gonna be a let's think about that. So no, I want a procedural mesh. So assets, procedural meshes. I think an icosphere is fine. And then I want a assets, materials, unlit material for that. I guess it could just take the same material. No, I don't want to take the same material because it's gonna be fading. Okay, so you get a renderer, oops, and that created a PBS metallic, which I didn't want. Also, this is way too big, so 0, 1. I think that as the end size should be fine. So let's play with this a little bit. So first of all, we're gonna take the unlit material here for the mesh renderer. And we want to tint it. I can maybe, like, I wanted to make it red, and I definitely want to make it somewhat transparent. Although I do need to set the blend mode to alpha for that. Does that work? I think toon shader. No, okay. So I probably want to always front, sideness front. Still doing the weird thing. Yeah, that now we are running into the age-old problem with game engines and transparency. Let's ignore that for now. Let's just set it to auto. And I'm gonna try to fix that later by just manually changing the draw order to something that works. But my idea for this is I want a... So this is gonna be highlight visual. And this is going to be... Okay, let's do... No, let's... Yeah, no, I want to make another slot under here. Highlight, and then we parent that there, mainly just so I have everything organized a bit. So we have the highlight thing, and we want a basically localized float here. Think we can just use a value field? Oh no, actually I think we should use dynamic variables for this. So on the entire thing, dynamic variables are really cool, basically named variables, but they are part of the hierarchy. I'm going to try to explain this a bit while I go along here. So under data dynamic, we find a component called dynamic variable space. I am actually going to give this one a name and set it to only direct binding. I'm going to explain what it does in a little bit. So let's call this Bezier visualization. Okay, so now we have a dynamic variable space called Bezier visualization, and importantly it's underneath this slot. So this is basically the root of this dynamic variable space. What does that mean? This means that now anything that is below this root can access this dynamic variable space and any values that are bound to it. So what does that mean? Well, on the highlight here, I'm going to quickly create a little slot, and I'm going to call it dynamic data. Boop. And I am going to set this to be at the top there. And on that slot dynamic data, I am going to do data dynamic. I want a value variable. Oh, okay. Small lag because it was generating the types of type float, right? So now I take the name of the variable space, Bezier visualization, and I'm gonna prefix that to a slash and then a variable name. So in this case, P0 highlight. And this value right now is 0. And that can also be 1, I guess. So how are we gonna do this in the sanest way? Can I do that? Okay, now I need to actually play around with this a little bit. 1 second. But the general idea is now anything that is in the same variable space, so the Bezier visualization thing, can read this variable. So I could make one like on the LogiX here, which is also going to be parented in there. I could access this variable, I could write to that variable, I could read it, and I could do the same on any number. Like all of these slots basically can now just access this as a shared, like global quote-unquote variable. But it's not really global because it's still contained to this part of the world hierarchy. I'm not sure that was at the correct spot, so let's find a new one. So my idea is I have a value 0 to 1. I'm gonna be localizing that, which I'm gonna show you how to do in a second. Which means that every write to that variable is going to be local, so it's not going to be networked. I think for that I want... So you can localize values by just... it's kind of a hack, but you can basically just say, hey, you know, I want to value copy the float into itself, enable write back, so I can still change this value. But because it's driven and drives our process completely locally, this entire value has now become a local value. So if I change this to a different number, then only I see that new number and everyone else will still see the old number. So I think I want drivers. I want to get a smooth value of type float. Also, let's quickly see what Windows wants from me. So the stream didn't die. I assume it's still running. It doesn't say anything else. Windows, what did you want from me? Oh, the WebSocket reconnected? Okay. It shouldn't have. Slightly concerned, but I think the stream is still running. It doesn't say otherwise in OBS, so I'm just gonna assume it is, and I'm gonna continue on. Right, so I can do a smooth value with right back. I think that should work, right? So if I now just take that one. Oh, it doesn't like that because it's already being driven. Okay, but I guess then this would also localize it. So the target value is 0 here. Or I'm gonna set it actually to 1. So this should also override, but if it's right back, I should be able to set this back to 0. Yes, and then it starts. No, wait. Why does it change the target value? I just want to change the current value. Oh, so I guess that's how that right back works, huh? But now I can change it. Huh, not exactly what I had in mind. So a value that automatically goes up, but that I can manually reset back to 0 instantly is what I want. So the smooth value directly. We could build this with LogiX, but I kind of had hoped we can do that fully in components over here. Okay, so let's, I wanna, yeah, the right back is basically writing into there, which is not, wasn't the idea. Okay, then let's see. We will probably have to do this with LogiX then, which is fine. So I still want to drive this field. So instead of because I want to localize it, so I am going to grab the interface card instead of doing what any sane person would do, and we're actually using the dynamic variable input node. But no, I want to drive it. So let's see how awful my little idea here is going to end up. Also, let's go a little bit down again. Right, because I can I can also drive the value by itself. So if I were to use a ternary, for example. So ternary, very simple. You have a boolean here, and if it's true, it takes the top value, and if it's false, it takes the other value. So my idea here is if we do this, so now we are driving that value, but we're also taking it as an input. And right now, though, it's true, so this should just be 0, right? Yes. And if I now flip this to false, it is still 0. But that is 0 because we aren't actually increasing it. So I would need to have some small increment by which that value is actually increasing every update. So let's do 0.001. Maybe that's a bit too slow. Oh, right. Now we have a value that goes continuously up. But if I toggle the boolean, it's 0. And if I toggle it back again, it starts from the beginning. That works. But now it's going up linearly. I would probably want that to be like easing in and easing out, like a sine shape. So I could just turn the entire thing into a sine. Oh, but that would not really work now, would it? Is there no simple solution to having a value that I can reset that just... I mean, usually I would just tween it, probably. Right, so actions tween. Issue being that would be synchronized, and I want this to be completely local. I guess this could work if I add another local register here. So this is just gonna be like a little internal state here, the float. And that is going to be what I increment. So we have that plus 0.01, so that's linearly going up. And I want to... Okay, now it gets... Now I'm editing nodes here, so this is gonna get really fun. I want to, on the node itself, localize it by value copying it into itself. There we go. So now this is a local float. Oh, and enable write back so I can still write to it. Oh, no, wait. No, I think actually we don't want... We're gonna localize it by driving it. So this is basically going, oops, to completely replace our first... Not what I wanted. Why did you snap there? No. Now I'm getting all twisted up in this. Okay, I will still need this. So what did I do now? I took a value register, so we did the same thing that we just did already. So we have a value that increments, and I can .025. I can start it again. 0.01. 0 to 5 there. That's what I wanted. 0, 0. So we have a value that slowly goes to 1. What was my end goal again? Right, I want to make a fun visual, so this would probably be a bit faster still. But now I want to clamp this. Operators. No, that's actually turning a... I think clamping is on the math then. Yes, clamp 0, 1. There. So I do switch that, but the end result there I want to clamp first before feeding it back. So now this only goes to 1. And this is local. Nice. So we created a local linear go uppy number. And now we can take this, turn it into a nice little sine shape. Right, because the sine of 0 is 0 and 1 should be 1? No, not quite. Pi should be 1? I think it's half pi. Wasn't it tau, Constance? Tau? Not tau then? It was one of these funny numbers. Oh, it's just 1/2 of pi. Maybe not that funny then. Whatever. So we can get the we can get 0 to 1 here, and we want to just multiply our 0 to 1 by that, and now we should have a nice sine curve. So if I toggle this 0, and now goes... Not even sure if I'm gonna change that again later, but let's see. So for now we have that, and that we are going to just drive into our local value here. So the only thing that is currently not local is the internal state of the ternary. So this is I probably do want to localize. That's that one, right? Oh, nope, that's what I wanted. Did this thing not have an internal state? Oh, then it's just evaluating this, so that we can just do oh no, I was thinking something different. I was thinking the flow Boolean ledge. That thing has the internal state. Yeah, that makes a lot more sense actually. So idea here being, I just want to quickly set it to true and then to false again, right? So I can do this. I'm not sure how quickly that will evaluate. So I set that to true and then immediately set it to false again. Does it work? No, that's too slow. So we would probably just want to add an updates delay. There is probably smarter ways of doing this. Delay 1 update. Delay 2 updates. That worked. 1 didn't? No. Okay, apparently have to delay by 2 updates then. So now we have a button, an impulse, which is gonna trigger our let's actually hook that up there, that looks a bit nicer. So now we have a button, and that makes our number start again. And it shouldn't be linear. But now the end result here was what I wanted to have. Oh no, wait, I was looking at the wrong one. Yep, nice. So now we have a P0 highlight here, and that we can use to, for example, drive the size of our highlight here. So I want a, I want a data dynamic value variable driver of type float. So we now take our localized variable here, and where's the component? There. And I can now use that on a gradient driver to drive two things. I'd want two gradient drivers. The first value gradient driver is just going to drive the scale of the sphere. So value gradient driver really useful because it takes a float input and has like pretty much any data type that as an output. So we want the float 3 here. So on the gradient driver we can just take the progress, which is 0 to 1. We can drive it from our P0 value. And then we can add points to it. So at point 0 and at point 1. We want it to start at 0, 0, and then we want it to end at 1. Right? So that would mean if I now use that, also reset the position here, and to drive the scale of our visual, and I pulse, then you can see we have a little sphere that expands. Okay, but I want a second value gradient driver now. For the tint color actually. So we want to first of all get another value variable driver of type float. I could have just copied the other one, but oh well. So we want to take our P0 highlight again. This technically doesn't have to be a dynamic variable at this point. This could just be a value field that we're driving. But that works. And then we want a value gradient driver of type color. So we do the same thing. We have a start and an end point. We take the progress, drive that from our fun value here. And now we go... We want it to be, let's say, probably red all the way, but the important part here is the alpha. I want this to start at full opacity and then slowly fade to red with 0 opacity. And that should be driving the tint color of the unlit material. Why? Because now, if I pulse this little button here, we have a nice little visual, which is pretty slow right now. So let's actually speed that up by increasing that number there. Oh, that's pretty smooth, I like that. That's a little bit too fast. 33. 35. Okay, maybe we don't want to start at full opacity, but 0.5. Just want to do a little highlight. Because my idea was I want to trigger that every time those up there trigger. I guess I could also use the same effect. I think I want to make this the size of the icosphere a little smaller, so let's do 0.75. Nice little localized display there. And I do that without spawning a new visual. So none of this is actually networked. Or it shouldn't be, because this is fully local. Yeah, so the way impulses work, they are all like, impulses are always local. So only the person that clicks the button will actually evaluate that. But if the result of an impulse is something that is networked, then everyone will see the end result as well. In this case, though, I explicitly made sure that everything that this impulse influences effectively is driven, and that means it's being evaluated locally. Which effectively means that only the person that clicks the button will now see the visual without using any other, like, trickery here. Yeah, I think it's probably fine. Let's make this a little bit easier to use still, so I'm just gonna call this data. Just clean this up because I just, well, like we just realized we don't really need this to be a dynamic variable. So I'm actually just going to do a float. So now that just broke. So I'm just grabbing that. There we go. So now we just have the end result here as a normal float, and then we can use a relations value multi-driver of type float to copy this. I forgot that this thing. Okay, if we only have two results, then we can also just value copy that. Value copy float. So from that localized progress. We basically get rid of the dynamic variable drivers here and here. We just take the two gradient drivers and basically hook them up directly, so that progress and that progress. Right. And for the impulse here, we are going to use a so let's see, at the top here I'm going to make a slot for dynamic impulse targets. So this is okay, so I should probably explain this. What I want to do now, instead of manually having a button here that you can click, I basically want to use this, which is a dynamic impulse receiver node. That's pretty cool. That's basically a little like remote controlled impulse, right? So I can just give this a tag. So in this case, P0 highlight. And if I trigger using a dynamic impulse trigger with the same name, I can basically from anywhere else in the world just trigger this, or I should be able to. I think maybe this doesn't default to... No, okay, so this doesn't default to the root slot. I'm just gonna quickly throw in the world root here to demonstrate. So slots, root slot, so this is the top of the world. And I'm just gonna trigger the dynamic impulse, and you can see this actually triggers here, and because this is hooked up to the rest of the code, that also should show my... Oh, wait, did I break the visual already? Oh no, I should probably just connect it up. There we go. So this also does now can remotely from anywhere trigger this. The issue here now is, though, this node, when I fire it, actually needs to find this receiver. And the way it's doing that is, if I pulse this, it will start by the input here, which in this case is the world root. It will go like through the entire hierarchy, everything that's under that slot, and find any dynamic impulse receiver, check its tag, and if it's the same, then it will trigger it, right? This is fine if you just have a single button that you click once manually. This becomes a problem if you have something, like if you have multiple of these and you do that regularly and it's doing a lot of hierarchy, like slot hierarchy traversal. So what you usually want to do is you want to try and be as precise as you can with this. So instead of aiming it at a root slot, I could say, hey, I know I only am going to use this in my like visualization example here. And I could take that as the input, and if I would have actually... Wait, let me quickly actually parent this to the highlight here, because that's the highlight LogiX. So let's do LogiX. No, not LogiC. We're doing LogiX. Let's just parent the red print. So now the red print here, so the code that we wrote is actually part of the hierarchy here. Right here, there you can see the... Should probably give this a name. Highlight effect or whatever. There you can see our highlight effect thing. So now, because I say, hey, start at the cubic Bezier visualization, if I pulse this now, it will still work, right? But it's now traversing a lot less slots because it's already now pretty condensed down to, hey, only fire that impulse through all of this. But the thing is, we are only ever going to have one of these that's responsible for P0 highlight, right? And we want to be with this to keep performance as optimal as possible. We want to be as precise as possible. So to be as precise as we can be, we will literally just take the receiver node itself, because that's also just a slot in the world, and we will directly target the impulse specifically only to that one single slot, right? Oops, not what I wanted. And then I pulse this, and you see it still works, but now it's not having to do any hierarchy traversal anymore. It's literally just a single slot, right? It's not checking anything else, it's just checking that slot to find the dynamic impulse receiver component. And once it finds it, it's gonna trigger it. This is like as precise as I can be. Only issue here now being, I want to probably, like the entire idea of this thing is that it's a dynamic impulse, so I can call it from anywhere I want. But now, I can still do that, but everywhere I want to be, I still now have to get a hard reference to that point there. And that's something I want to avoid. So what I'm instead gonna do is I am going to create a variable, which is called just on a slot dynamic impulse targets. That's just my naming convention for it. I'm going to put a reference variable here of type slot, right? So I'm going to store a variable, like like the reference to a slot as a variable. And I'm going to take our dynamic impulse receiver slot, plop it in there. Now I'm going to give it a name. We have our dynamic variable space here. Boop, Bezier visualization, and I'm going to do slash. So what I did usually is I basically use the same name as the namespace here again. So I would have another Bezier visualization just to prevent any potential name conflicts. Visualization, yes. Dot, and then I'm going to use P0 highlight here. So copy that, paste it at the end. Right, so I have bound to this dynamic variable space a variable that's got just space name dot P0 highlight. I probably honestly don't need the space name there. It's just like my convention, so, because I have like some stuff that's like stacked together and sometimes sharing the same visual space, so whatever. And now anywhere in the hierarchy, because it's a dynamic variable that I can access from anywhere, I now have access to the reference of that that receiver, and well, I can basically just now remotely trigger that by pointing it directly at the slot, so I avoid the entire hierarchy traversal. But I still have the flexibility of being able to like remotely trigger that thing. So P0 highlight is probably fine. I think that's pretty much all I want to do here. Yeah. Okay, so this is all I want to do here. So what I'm going to do is I'm not going to touch this again. I'm just going to pack it. And now I have my highlight here with the LogiX that I can now remotely trigger. And I probably want the same highlight on all the other points as well. So let me just copy it a couple of times. P1, P2. Oh, did I, what? Oh, I put it in the text. That's obviously not what I wanted. There. So now because I know the code, it's only 18 nodes here. Now I am going to change my string input here to be P1 highlight. P1 highlight. And I'm gonna grab the dynamic impulse receiver here again. Or rather go to my dynamic data, copy this. Do P1 highlight. And just hook it up to the other receiver under P1. And that I'm just gonna do 2 more times now. So I'm gonna go here, I'm gonna change the string input we have to be P2 highlight. Although technically I could just... I mean, technically this doesn't have to be a different name, I guess, but I'm gonna give it one anyway, because otherwise I'm gonna get very confused. Dynamic impulse receiver. So just that. This is now P2 highlight. And then one more. Doop, doop, doop. You are now P3 highlight. P3 highlight. Grab the receiver. Throw it into a new variable. Also make sure to rename the variable, because you see if I duplicate the thing, it actually does duplicate the value, but I rename it before I actually assign the new reference to make sure these are all now different references. So we have A77, A97, AB, and yeah, they're all different references to all the different dynamic impulse receivers. Yeah, so now I can very easily target each of their highlights. Nice. So let's add one more. I can probably get rid of that red print there for now. So we have our things here, which are locally fired whenever the client sees the value change. I'm gonna add one more, but now it's gonna be a larger or equals, because it's gonna be equal. So same value, 0, 1, now this is just 3. Can probably... might be able to clean this up a bit. I don't think that's making it cleaner. Yeah, it's just making it more confusing to look at. Whatever. This code doesn't have to be pretty, it should just be the presentation, the visualization should be pretty, but the code itself, no one is gonna look at that. Well, except me and everyone watching. Right, and then I'm gonna basically have one more here, so we basically... The idea now here is we have an animation, like a driven animation, that is controlling the state of our wire. And at every point it's basically triggering an impulse, right? And we already have our localized... we already have our like localized little impulse on all of display thing on all of these. So what I can now do is... Now we want to go into okay, so what we want to do is for each of these impulses we want to trigger a different dynamic. So first of all we want to have a dynamic variable input so we can actually get our target here. Although no, I want to actually use a read dynamic variable of type slot. You will see why in just a second. By the way, if you don't give this thing an input slot, it will just act as the dynamic variable input, which is what I want. Now we get into the territory, like I could basically just write this out like 4 times here, like, okay, on this impulse, like send to that, to slot 0, send the impulse fire 0, or like visual 0. Then on 1, like read slot 1, fire impulse 1, on 2, read slot 2, fire impulse 2. But that's very repetitive, right? So how can we make this a bit more nice to look at, right? Because we don't want to write the same code multiple times as we've done down here, which we had to do because they are all individual drives. But now we are now in impulse land, right? So what can we do? We can use a impulse demultiplexer here. Impulse demultiplexer is a very, very cool node because it just takes any number of inputs, in this case 4, and it combines them all into one single impulse. But it's not just an impulse, it's also an impulse with impulse data, and in this case an integer, which is the index of which this has been fired from. So for 0 this will be 0, for 1 this will be 1, and so on and so forth, right? And I can combine this with a value multiplexer, or just a multiplexer here, to turn that individual, so I'm gonna need string inputs here. String to turn that index just into one of our 3 keys. Right, we have, or 4 keys, I guess. We have P0 visual, P1 visual, and so on and so forth. So P0 highlight. Also, let's actually create one more here. You will see why in just a second. P0 highlight. And then we have P1, P2 and P3. And we just have that so this is the variable name, right, that we want to read the variable from. And then these are all our impulses. And because the variable name ends with the impulse name, what we can do is, because we're lazy, we will just do a little string concatenation here. We will say, hey, you know, this plus the name, which will now for us always be 0, but for the impulse it might be any of 0 to 3. So we get the variable name that way, so we can read the dynamic slot, and you see, oh, it's an impulse receiver. How convenient. And that works because, again, this code is now actually part of the hierarchy, so it's underneath of our dynamic variable space, so it can access all of these variables. Awesome. So now that we have that, and we also have the impulse name, we can very easily just do a flow dynamic impulse trigger. We take the name 1 here, and the variable we read is basically the output. So what's gonna happen here, right? So we fire an impulse, and that goes in there. Okay, so we fire an impulse, right, based on when one of these, like when our line basically reaches each point. We fire that locally, so that will be evaluated for every user, like every time their client sees the point reach that value, that step. And we combine this all into one impulse with an impulse demultiplexer. It goes to the dynamic impulse trigger. And what that is doing is, so first of all, this based on which of these fires, this will be a different number, 0 to 3, right? And then we basically take that number 0 to 3, the index, and we can convert it into our string value here, right? Because P0 highlight, P1 highlight, P2 highlight, P3 highlight, those are the names of our impulse, or the tags of our impulse receivers. We concatenate that with the full name, like the start of the name of the variable, which references the slot of the individual impulse receivers for each of those tags. Right, so basically that's a very fancy way of saying we take this string and append one of these strings based on whichever impulse fired. We read that dynamic slot, which is going to be our impulse receiver for that individual impulse, and then we just trigger the dynamic impulse here, and then we're done. Yeah, I think I'm just gonna keep it down here. That looks kind of nice. Right, so if everything here went to plan, we have our value, which is currently at 0, right? So once we start moving, we should see 0 pulse. Then once we reach 1, 0 pulses again. Wait, what? Why? Ah! It worked. Okay. So when we duplicated these, we didn't actually reset the transforms of all of our highlights, so they were still all in the same space, because when you copy a slot, by default it remembers where it is. Okay, so let's do this again and be a little less confused. So we start at 0, 1, 2, 3. Nice. Nice little impulse-driven animation here. Perfect. Precisely what I wanted. Pew, 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 pew. And it is fully local. Oh well, yeah, we're not actually changing anything in the word hierarchy for this, which is pretty cool. So this would be the first step of our animation, which is we have our points and then we just animate this so it goes through each of these and pulses them. And it shows a little highlight every time it reaches the point, which is a very nice little detail. I like that. Pew. Then the next step would be we have our line here. And then the next animation would be we make like the points show up on this line. Although actually I'm just now thinking. This is probably fine. I was thinking if we should have just one visual that like moves around and stuff instead of having this code multiple times. I think this is fine though. And better, because if it moves fast enough then we can see multiple visuals at the same time. So that would be the first animation. And then what we would want to do is spawn intermediate dots for the t value. Right, so we would just take, I think it should just start with 0.5. So this defaults to 0.5 and then we do like point on the middle, which is very easy to follow, and then we do lines again and then point in the middle and one last line. And I like this. So after this animation is done, we want to spawn new points. So we would need 4 more points. Which I think I might just take the same visual here. Just a smaller point. So maybe we should actually think a bit about the looks of everything. So right now the points are using the toon shader, which is not good. We didn't actually give those any very distinct values here. So let's change this around a bit. So we want a unlit material, simple one, and then 0.51 on the color, so 0.510, and that was 0.75. And we will just completely nuke the XIC2 material and instead give the mesh renderer the unlit material. Okay. I do want the black outline though, so instead of doing that with the toon material, we're just gonna do a little trick here, and we're just gonna do outline. Which is gonna be a assets, procedural meshes, sphere again. So wait, which one? Were you an icosphere? No, you're just a sphere mesh. Do I want to use an icosphere instead? I think I do. They don't have poles. So let's do an icosphere there and also here. I want them to be all individual meshes. Assets, procedural meshes, icosphere mesh. So we have our little icosphere here. We are plopping that into the mesh renderer. It's very big, which we don't want, so we're gonna make it smaller. So smaller radius, 0.1 is still very big, so we want 0.01. I think that's about the size that we used prior. Yeah, that looks good. And then the outline, which I already added an icosphere mesh as well. This is gonna be 0. Actually, I can probably make this shared meshes here. So let's do a slot called assets, and then meshes. Just to kind of share it a bit, and then we're gonna have the 0.024 icosphere. So we are just gonna put the assets, procedural meshes, 2 icosphere meshes. I'm gonna show you why in a second. So this is gonna be 0.01 and this is gonna be 0.012 maybe. So first, this icosphere mesh is the one that we use in the mesh renderer here. And also all of these consecutive mesh renderers. So remove the sphere mesh. Remove the sphere mesh. Remove the sphere mesh. And then for the outline here, we just want another mesh renderer. We want rendering mesh renderer. And we want to take the 0.12 mesh now. Boop. So now we have a little bit of a bigger mesh here. So let's do one shared materials. And this one I'm just gonna make black. So we're just gonna have a unlit material here. Assets, materials, unlit material, which is gonna be the same opacity, so 0.75, but it's gonna be all black. So that is the one that I'm gonna use on the outline. And now my idea here is so now the material, basically the outline renders above the thing, which is not what we want. But what we can do is we can basically just invert the mesh. So now there's 2 ways of doing it, I'm thinking. I'm not sure which of those are going to work. So I'm just going to try to give this one a negative radius. And that works. Perfect. So now we have our inverted icosphere mesh, basically. So it's only one-sided, so if I invert it, you basically see the inside. But since the actual point is like on there as well, it appears as if it's an outline, even though it's not really. It's just 2 meshes that are stacked on top of each other. On the one sphere you look at the outside of the sphere, and the other, like the outline sphere, you look on the inside. This should be a lot more comfortable than the alternative approach there. So let's make it a bit thinner. So there we have our outline point. This also has the nice benefit that we are now no longer... Oh wait, no, that's actually not what I wanted. That's only because I didn't actually set this under material to alpha. Although maybe I just want to keep it like that. No need to see the inside really. Because the inside is just ugly with the two spheres there anyway. I think I like this. I think this is a good way of doing it. So, okay, so let's quickly... I'm gonna keep the materials individual here still. Just a couple another unlit material. So let's see, we don't need that interface proxy. So this is just 0, 1, 0.5. So 1, 0.5 and that was 0. And that goes there. Yeah, I think we're just gonna keep it opaque, and then I'm just gonna take our outline here, duplicate it, and now actually do reset the position, and you see, hey, we have a second outline. So let's do the same again here. The color is 1, 1, so that's easy. So let's do another assets unlit material. So 1, 1, 0. 1, 1, 0. Use that for the mesh renderer. We don't need an interface proxy. And the same at the end here. So that's just 1, 0, 0.5. Assets, materials, unlit material. 1, 0, 0.5. And I mean 0.75, sure, why not? And then we take that and we throw it in the mesh renderer. We get rid of the interface proxy, nice. And of course we're gonna have to duplicate the outline once for P2. Reset the position and duplicate it once more for P3. Reset the position again. Hey! Same effect, all unlit materials. Nice. Okay, and our animation should still look somewhat decent, I think. Yeah, I still like it. I still like it. Okay, now let's quickly leave the points alone and think about how we want the lines to look. So let's take a look at line 0, because right now this is a PBS metallic. So one fun thing that we could do, maybe, is instead of making it a single color, we could try and make it a gradient from P0 to P1's color. From P0's color to P1's color. How would I do that? It kind of depends on how the normals look on these generated meshes. Normals, how do you look? How do we figure that out? Okay, so on here, I'm gonna quickly go into my inventory, and I am going to look for a texture which is in Neos Essentials, which is under Assets, Textures, Gradients. I just want... Give me 2 gradients here so we can try this out, the horizontal and the vertical. I think... oh, that almost looks promising, but not really. Okay, that's not really at the halfway point. So if this was set to have the texture that I'm using here for the gradient. If that was set to repeat instead of clamp. Yeah. Okay, so it is generating... it's doing it for every segment, so unless there is a way for us to change how the VUVs are laid out there, we can't. Actually though, maybe we still can if we don't use textures for this, because there is a very fun material. Oh, but okay, that's gonna be experimentation grounds though, so let's actually go over here to figure this one out. Also, I am quickly going to take another sip of drink, which is totally not filled with sugar. No, I'm... of course, only drinking healthy stuff, but you cannot see, so you cannot judge me. So, okay, for this I actually want a tool from from the Essential Tools folder, because I'm too lazy to build it into my multi-tool so far. Material gun. Let's create a new... So there are some special... I think it was actually a unlit as well. Unlit distance lerp. I think this was a very fun thing. So near color 0, far color 1. Although that's not the material that I had in mind, actually. Interesting. So this has a point in space that it references. Okay, so by default it's using the global space. So let's quickly create a little sphere here, just so we have something to move around and use as a gizmo. So let's just make that small, so small. And let me grab, using the LogiX tip. Actually, I didn't want to close the inspector on that so quickly. Using the LogiX tip, let's quickly grab out the interface card of the slot. And now we have a position there. Although we want to transform local to global, which I think it doesn't matter here, but let's just make sure that that's not our issue. So we need to take the position, and it's in the space of the parent. Or does that not... Wait, really? Why does that not work? Oh. Okay, well then. Why does it even have the parent slot then? Oh, so you can drive it probably. Yeah, okay, so then let's do get parent. Get parent slot. So we take our little ball here, get the parent slots, and we convert that to global space. So this is the global space position of the point. And I am just gonna use that to drive the point on this material. Because that would already, I think... Okay, so let's change the distance. Let's change the distance to 0.25, 25 centimeters. Yeah. Okay, so we can use this to have a gradient, like an unlit material that's spatially like a gradient between two points. If we hook the left side up to the reference point of the surprisingly it looks a bit, it blends a bit weird though. Oh, that's probably the transition range, so if I make this 2.5 as well. I still see this. A double of that? I still kind of see where it swipes. Well, like this, we had gone off the swipe, but now we don't actually reach the full. I want it to be 1 when that thing is directly in it. So what would I have to set the transition range for that to be the fact? So it's not. So 0.25 is. Nope. But if it's 1, then we never reach it, which is interesting as well. It's not the full thing. Oh, maybe it is actually. No, it's not. Okay. Ah, okay. I think I see how the transition range actually works. So we have. Well, that's kind of cool as well. So we basically have a. So this is based off of the distance, so that's just the hard cutoff point. And if I make this 0.5, now I need to move forward to it, but I still see the slide there. So what if I just set the distance to 0 then? And the transition range to 1? No. So now we will never see it. Transition range is 1. Now it will always go basically to half brightness. It will never reach full brightness like this. Okay, actually let's just make a second point here. So let's duplicate our point. Let's take the one that's not already hooked up. So we have a point A and a point B. We want the same thing again, so we want our oops, not editing whatever I want to edit there. We have our point, we quickly get it to global space. There, so same thing again. Let's move that down here though. Okay, so now we have 2 points. And we want to basically figure out how we can make this, because we only have 1 point input here, so we want to make sure that. So first of all, we're gonna get the distance between the 2 points, right? That's easy. So we're gonna do variables. No, transform. It should just be. Wasn't there one that's just math vector distance? Okay, I know there is a distance node somewhere. Just not sure where that is right now, interestingly. Fairly certain there was an operator for that, or like maybe not an operator, but there was a node for that. Which, I mean, would make sense under here. So maybe not. Okay. If you can't find a node, what do? You get out the node searcher. I still use the old version. I should probably start using Yuki's new one. But I know there is a distance node somewhere. Operators, what? But I checked here. No, didn't check good enough. Fine. You do you. There we have the distance between the 2 points. Perfect. So P0 is gonna be the reference point, and I guess the distance is just gonna be the distance. Let's actually set the transition range to 0 for now. So that point is the start point, this point is the end point. So now it's actually right at that. Right, so we want to set this to be half of the distance, because that's going to be our transition point. So we want to divide that by 2. Wasn't there even a single node for that? Divide by 2? No, maybe not. Take the distance, divide it by 2, and make that the distance on our material. So now right in the center of these dots is basically now our transition barrier. And I assume now we just want to make the transition range to be the entire space, so the entire distance between them. That looks like about half wide. Not quite. Also distance by 2. No, now it starts here. So 0, 1, 0.5. So the transition range, I mean distance is half of it, so the transition range I would have said would just be the full distance, right? But now, oh, because oh, it's just offset by whatever half of this is. So distance minus half of itself. No. Oh, because Yeah, that actually does not make too much sense. Maybe I just want the distance to actually be small. Oh, I see. Okay. So what we want to try is we want to try. So we have the distance divided by 2. Which gives us nothing, just the distance alone is gonna be our transition distance. Then we're gonna have a constant, which is effectively just the size of that thing. So in this case, I can get the size if I just unpack, but obviously that would have to be proper getting the size, and it's the same right now. But this is basically the size of our ball right now, right? So I want to set that as the actual distance, maybe? Maybe not. Or is this, does this now depend on the size of the... No, it shouldn't. Doesn't quite get just a small distance into large transition range. Ooh. People are joining, and I think I'm standing closer to whatever this freaking speaker is now, because that was really loud. I need to build my own walls. That's what I get for just... That's what I get for just grabbing an existing one. I just wish there was a way to know. Oh, spawn sound, I found it. It's in the spawn area.
Hello.
No, goodbye. Hello. Greetings. I am trying to figure out funny materials unlit distant lerp right now. Welcome to the workshop. I hope you're having a nice time.
Yeah, I am.
Nice. Also, let me grab the streaming camera. I think it's not necessarily necessary to see my first person right now because I'm just messing around anyway. Yeah, so welcome to the workshop. If you have any questions, feel free to ask them. I'm right now just trying to figure out how to get the effect that I want.
What are you trying to get it to do?
So I'm basically the idea here is I'm working on a little visual. So let's just make the transition range 0 right now. So the what did I break it? Oh, because this should be distance divided by 2. 1 second. Divided by 2. There. So basically I have a material here which is like like based on these two control points, it's like fading from white to black.
Mm-hmm.
And I'm trying to figure out how I have to change the transition range. So it is a smooth color. I thought I just have to put the entire thing in here. But it doesn't look like it's actually working in the way I thought. Because it's not like fully black when it reaches that point, which confuses me a bit.
Yeah.
But it might already be good enough. I think it's... But the half as well doesn't really work. Because now it's like... transitioning from here. There, and then it starts fading to black. So now that works, but now the transition point is like in the middle, which is not what I want. Because now it's only fading on the second half of it.
Yeah.
So, I mean... Not quite sure why, so that's the closest I got so far. I guess I would still have to turn the range down a bit, but I don't know, I'm not sure based on what. So it's larger than half of it, but it's not the full distance in between them for some reason.
Mm-hmm.
Yeah, the general thing is I'm just over here, I can show you. Working on a little visualization for Bezier curves.
Oh, okay.
So we're working on some procedural animations. I mean, just basically because no one else is around and I can't answer any questions, so I'm just working on some random projects.
Mm-hmm.
So it like, we want to make like a nice little animation when it goes from like left to right, and then it like would put the points in between each of the lines, controlled by the T value here.
Yeah.
Which I guess can simulate. So, and then it would like actually draw the Bezier curve along that visual to show how it works.
Mm-hmm.
So I
Makes
want to
sense.
basically do lots of funny animations here.
Funny little animations. Magic.
Yeah, and the idea was for these stripes here, for the lines in between, I basically wanted to do the little to fade from the color at P0 to P1, so from blue to green here. Mm-hmm. And for that I was trying to figure out how I can abuse the unlit distance material for that. Which I want to say it should work, probably. I'm just really confused why... Don't know, actually. Wait. Oh, that's the full range again. So what is missing here? Why is it not... I don't quite get it. Because if the... I think the transition range, I mean this should, in my head this makes sense, just the entire distance is the transition range. But it is offset by a fair bit. I mean, I don't just want to type in magic numbers to find one that works, but it might just be what I end up doing here. Because I have no idea why this is behaving how it is.
That works better.
Not really. Yeah, now the transition range is really small. Oh, but even now it's not. Wait, that's the middle. I didn't change the distance. The distance is still just the same. Oh, I see. Okay, so the transition range, so the middle basically says this is where it's white, and then the transition range is not starting at that. So this will stay on that gradient even if I increase that? No, now it's well, still kind of there. But now it's not anymore. Now it's here. So it doesn't seem to be blending in like both directions with the same... But
No.
why? Why? I mean, if I like this is the transition range, I would have thought that would be like in the middle if I said it. It seems to be. Yeah, it seems to be blending to the right first.
Someone needs me, so I have
Oh,
to keep
okay.
going.
Have a good time then. Bye.
You too. Bye-bye.
I'm gonna figure this one out. Oh no, they broke. Also, I should probably get the chat here, but no one has written in a while. I hope you're still enjoying the stream, everyone who's watching. I mean, at this point, I'm just getting very confused. Yeah, so 0 is just like exactly in the middle, which is exactly what I want. But 0.5, or like, I'm gonna do 1, and why is it first blending in the other direction? I don't get it. Yeah, this is confusing me. Well, so what do you want, Windows? You want to tell me that YouTube videos have been uploaded? Thank you. Need to figure out how to turn off desktop alerts. Why is the transition so weird? Why is it not behaving like it should? 0.1. Yeah, it's not at all like 0.2, it's still kind of there. 0.3, it's now starting to get shifted over. And now it's like just getting harder to see. But I mean, I can just make this bigger. Right. Okay, maybe let's go back to smooth PV now that there's a big ball in the middle. Seems to be going to full black and to full white. Wait, does it really? But now it's just at 0.5. That's the same. Wait, this is just some weird visual artifact? PBS metallic on root. Oh no, wait, that's the small sphere. Well, I mean, this is the material that we're editing. I just want to quickly get that out. Blend mode is opaque. Zero it on, please. Why can I still see through it? Why can't I see through it if it's opaque? Wait, is it the same with every unlit material? Can I also see that? I can't see through that. What the fuck? Yeah, something is weird with this material. Because I can... Why can't I see? I mean, what can I even see through there? It's not... Looks like I can only see the AO through that. It's not transparent. Oh, but if I set it to transparent, But I can still see a very, like, visual cut there. So I might just... Is this gamma correction? Do I just wanna, like, multiply the value here with, like, some constant? Because this should just be properly fading, right? Okay, so if I turn the entire thing not to 0 but to 0.5. Okay, I don't think I want to do that for both of them. That point stays there. 1, 0.9, 8, 7, 6, 5. Not really. Maybe I'm thinking too much about this. Maybe I should just take this and accept it. I mean, this gives me basically the effect that I want. Minus some visual... No, but it's definitely... So if I just change the white to... No, I can, like, there's definitely a ring there. Like, there's a very clear cut and I have no idea where that comes from. Fine enough, opaque doesn't seem to be opaque. But transparent seems to be opaque and alpha. Yeah, this is still doing something weird. Okay, it looks better if it's not black and white. No, but I can still see the rings. I think I want this. This looks visually the nicest. Okay, well then, at least that's sorted out finally. Materials using the global space. So let's basically just grab this. So since we have a slot transform anywhere, let's just use global transform. No, that does of course doesn't work as long as it's still connected. So we probably just want global transform for the slot instead. Yeah, that looks fine. And then we just want transform, global transform. I think there's also this is probably fine. So just our two slots here. So this will basically be on every line to drive the material. And also near color, far color. So I think we also just want a redynamic variable type color. Yeah, so I think we're just gonna do dynamic so on the slots here we would do, although actually I think I might just point A and B. And then we just have two colors as well. one of them is gonna drive that near color. Although I do guess I could also just drive those with components instead. But it's fine. Because we have like a limited number of points here, I think I'm just gonna make a variable for each. Okay, that's good. At least we can, oops. At least we can see it if it snaps on the red print. Somewhat. Okay, so let's return to this. What's my camera? Where's my camera? Oh, did I close it? I think I closed my camera control panel. Ah, okay. No, I didn't. It was just behind me, I guess. Where am I standing? I'm standing the wrong way around. That explains it. Let's get chat back again. So we have our code for the material. But we will probably need a new material on here. So, okay, so first line 0. You will be our start. Also, we will want to so on these I'm just gonna have dynamic reference variable slot. And then also a dynamic reference variable, no, wrong, dynamic value variable of type color. So for each, I'm gonna call this just, what did we call the variable space? Bezier visualization. So let's go to P0. So this name is gonna be the same. P0, so the slot is gonna hold P0, and I guess instead of you doing a dynamic value variable of type color, so I'm gonna call this P0. I can also just make this a field, dynamic field of type color, which I'm just going to give the same name because variables are always defined by the combination from name of type. So I can have two different variables with the same name but different types. And this the difference between dynamic value variable and dynamic field is, instead of creating a new component that like holds the like a new variable component that has like an actual data slot in itself, I'm saying, hey, you know, see this data that already exists somewhere else, basically treat it as if it's a dynamic variable, which is really amazing because that means you can basically save yourself like a value copy there by just pointing it directly at that. So if we change this now, because it's a variable, that basically changes everything else. So we want to do the same, I guess. I'm gonna just grab a component clone tip for this because that's easier. Component clone tip, very awesome. Oops, didn't want to actually grab that out. So we have P0 here. So reference variable, we copy that into the component clone tip. And then I can just go to P1, click the handle, boop. P2, click the handle. P3, click the handle. And now I just have the variable on those as well. So this is gonna be P3 and hold the reference to P3. this is gonna be P2 and hold the reference to P2, and this is gonna be P1 and hold the reference to P1. What a surprise. Let's also do the same with the dynamic field. Actually, no, I shouldn't do that. Okay, but if I were to value copy that now, yeah, let's instead just have add these manually. So attach dynamic field of type color. No, I guess I can just copy the empty one because that doesn't break anything. Okay, so we have P1 color, P2 color, and we have where's the field? Why are you down there? Color. Nice. Okay, so now we have the points and the colors as variables. I did it this way because it's easiest. Okay, so now let's do LogiX subslot for line 0. I'm just gonna put it there because I don't know, it's the only part that's actually gonna use that material. So you will basically parent yourself there, and I'm gonna call this material drives. So let's see, on here now we already got rid of the old material. We don't need the interface proxies. We just want a assets, materials, unlit distance lerp. Yeah, I don't think there's... I want it to be unlit, so we can't use the PBS lerp thing. And that's basically now just gonna get rid of that. This is gonna basically completely replace this part. Those drives are now all broken. Great. Maybe I should have thought that through. So just grab that material from L0. So we have point. We have the transition range, I think, and the distance. Okay, and now what we want to do is we want to make that goes from P0 with the color of P0, which is going to be the near color. No, the near color. There we go. And that should already... Oh, no, we haven't actually assigned that material to the mesh renderer. No, that's point L0. Take our like driven distance lerp, hook it up to that, and that should already look almost like what we want. Okay, let's do P1 next. So P0 from P1, both in color and in space. That sounded cooler as it was meant. I mean, like spatial relation. It's not actually in space. Oh, that would be kind of cool. Okay, and it's not what I want. Why does it look different? Maybe I did mix them up, so maybe... No, the distance should, because... This is 0, right? Oh no, wait, the distance. Huh? Wait, why does that look better? I did it wrong. Yeah, no, I did it wrong. So that's not transition range, just distance without transition range. What? Wait, what did I do? The distance between P0 and P1. P0 and P1. Is it over here? Getting very confused here. It's not changing. What? But the position is changing. The position is not changing. Oh, wait, no. No. Dynamic reference variable slot. P0. P0 parent points. Give me the global transform. This shouldn't need an updating relay. I think. Transition range is 0. Distance is something, not 0. It's not updating. Okay, wait. I'm honestly a little surprised that this is not updating. Really? I shouldn't need an updated relay for this. Why are you not updating? That's very stupid. I'm not gonna do that. Then I guess you are going to be no dynamic variables, so but literal just reference errors. Because screw that. Guess these register themselves to them. I never had that issue with transform nodes. I don't know what's different here. But now this should work, right? Yeah. Without updating relays, fine. And now I can hook the distance to the transition range and call it a day, I think. And now it works, like somewhat, kind of. Why is it? I mean, it's somewhat lerping. Not very nicely. Oh, this one. That shouldn't matter because I'm not really using. I guess I should probably at least make sure they all have the same opacity, even though I'm not using it right now. Yeah, that at least works. It looks a bit different than I had in mind. It's probably fine. Actually, I think I'm not gonna parent that there. I'm gonna make that global. Probably could do the same for these. I'm gonna call this line material drives. No, new logic slot parent. Okay, also let me check. Yeah, we have been streaming for quite a while. Let's just do this same thing for the other two lines at least and then call it a day. So we want another assets, materials, unlit distance slurp. We want to use that in the mesh renderer and we want to have that here so we can define it. Okay, so let's see. 0, 1. I'm just gonna mesh this for all the lines together because we're gonna need all the points anyway. So might as well just throw that all in one piece of code. since it's all gonna be static now anyway. So that's one material there. Let's see how I can make this look not too bad. Right, 1, 2, 3, 4, or rather 2 and 3 because we're 0 indexed. And let's see, so this is the second material. So now we basically want to do the same thing, different distance. So first global position to point. Let's see. Oh, actually, we want that one. So. I think we can't make it super fancy here. Yeah, something like that. Something like that. We take the distance into the transition range. The distance divided by 2. Into the actual distance. And then we have near color that one, far color that one. So I guess I could maybe move that in between there or under that. Because this is going to be moving down quite a bit again. I think that works. And then I'm going to have at some point the global transform here. We're basically doing this final time, something like that. Okay, let's see. So we will need... Oh. It looks like it's not blending properly. So what did I miss? Green to yellow. That doesn't look right. Oh. Maybe actually use the correct node, that would help. Better. Yeah, it's not perfect. But it's probably good enough. And then we just have L2 here. Do the same thing a final time. Don't need the PBS metallic anymore. You get a unlit distance lerp material. I can probably also give that an outline. The same way we did with the other one. Okay, so let's see. Doot. point. Yeah, I am noticing this is very slow workshop today, which is fine. I mean, I'm getting some work on some nice visualizations done, but with slow I meant not really many people I can help and answer questions from. Which, I mean, at least means I make some progress. No, I do love answering questions, that's why I'm doing this, but I mean, I'm also doing it at a very awkward time, so I'm not expecting many people to show up. Because most people on Neos are kind of living on American time zones, I want to say. And less is actual European like me. So yeah, that's just a new color there now. And then the far color. Let's apply it to that thing. Yeah, that's definitely not reaching the end there. So I'm gonna have to figure out what my error in the syncing process here is. Because I honestly don't know. This feels like it should all work. Oh well, whatever. So we have one piece of code now that's taking care of all three materials. Could add an outline, but honestly I think we have done plenty for one day, and I think since there aren't too many people here right now anyway, I'm just gonna move this back into a nice place. And call it a day. So let me wrap this up, pack that there, and pack all of this. Oh, and of course people join. Every time. That's fine. Do. I do want to save this though. So let's see. My stuff, projects, curves and splines. I don't want to save this. Hello there. Greetings. I hope you are doing well. I am live, yes. Welcome to the internet. No, don't worry. Okay. It's fine though. Honestly, I was just about to wrap up because we've been streaming for almost 4 hours now. I think that's long enough. So yeah, where's my camera switcher? There it is. There, third person. Okay, well, we did some progress on a little visualization tool. Was a bit of a quieter stream today, but I mean, we have those as well, right? Thank you all very much for watching. And I'm gonna probably be back here same time next week. So we'll see you there. Bye.